Imagine standing on the edge of eternity, surrounded by a vast cosmic ocean where silence reigns. Then, in the blink of an eye, a powerful burst of energy flashes across the void, a signal so brief it disappears before you even register it. It's unlike anything we've ever heard before. Could this be a cosmic cry for attention, a message from across the stars, or perhaps something even more mysterious? These are fast radio bursts, one of the most baffling and powerful signals ever detected in space. What could be behind them? So, what exactly are fast radio bursts, or FRBs? At their core, FRBs are incredibly powerful bursts of radio waves that originate from deep space. These fleeting signals are short, lasting less than a millisecond, but in that brief moment, they emit as much energy as our sun does in 3 days. Discovered by accident in 2007 by Duncan Lorimer, these signals have baffled scientists ever since. Since that first discovery, over 1,000 FRBs have been detected, but each one seems to raise more questions than answers. They come from every direction in the sky, and they don't follow any predictable pattern. Some repeat from the same location, others appear only once, leaving behind nothing but mystery. Imagine standing in the quiet of the cosmos and suddenly hearing a powerful sound, a single burst, brighter than anything else around it. But then silence. We've been listening to space for decades, and nothing quite like this has ever been heard before. Could these be the death cries of collapsing stars? The violent interactions of neutron stars and black holes? Or is there another explanation, one we haven't yet considered? So what could be powerful enough to produce a signal that travels billions of light years, reaching us here on Earth? Some of the brightest minds in astronomy have turned their gaze toward the cosmos, and their answers are as astonishing as they are complex. One of the most compelling theories points to neutron stars, among the most extreme objects in the universe. Imagine a star collapsing under its own gravity until it's no more than 20 kilometers wide, yet with the mass of the Sun. Now imagine that star spinning rapidly, and its magnetic fields becoming the strongest ever observed. But not just any neutron star. We're talking about magnetars, neutron stars with magnetic fields so intense that they could distort space itself. These magnetic fields can generate explosive bursts of energy, sending out X-rays and gamma rays. Some scientists believe that in certain moments of extreme magnetic stress, a magnetar could unleash an immense burst of radio waves, an FRB. And yet, even this theory doesn't fully explain the diversity of these bursts. For while some FRBs repeat, firing off in bursts from the same location, others are one-hit wonders. They appear, disappear, and leave no trace of their origin. Could it be that multiple phenomena are responsible for these signals? Some linked to magnetars, others perhaps the result of an entirely different cosmic event? Imagine this: two neutron stars spiraling toward each other in a cosmic dance, orbiting closer and closer until they collide. The energy released in this final violent moment could send shockwaves through the universe. Some scientists believe that FRBs might be the echoes of such colossal collisions, signaling the end of two stars and the birth of something new. These theories, neutron stars, magnetars, collisions, are all incredible in their own right. But for each answer we find, new questions emerge. Could there be another force, even more powerful than we've yet imagined, behind these bursts? Or is there a deeper mystery, still waiting to be uncovered? And now we turn to the most speculative and perhaps most exciting theory of all. What if these signals aren't just natural cosmic phenomena? What if they're deliberate, created not by stars but by intelligence, by civilizations far more advanced than our own? Some scientists and many dreamers have asked, could fast radio bursts be the work of extraterrestrial civilizations? It's not as far-fetched as it might sound. In fact, renowned scientists from Harvard University have speculated that these bursts could be used to power interstellar ships, light-sail spacecraft that are propelled across the universe by bursts of radio energy. Think about it. If these signals contain enough power to accelerate massive objects through space, could we be witnessing the handiwork of advanced beings traveling the stars? The theory is grounded in real physics. We already know that light sails are possible, using light to propel spacecraft across distances that were once unimaginable. If an alien civilization has mastered this technology, perhaps what we're detecting isn't a cosmic coincidence, but rather a purposeful signal, a sign that we're not alone. Of course, most scientists remain skeptical. The idea of alien signals is exciting, but the evidence still points to natural explanations. And yet, as we've seen with many cosmic discoveries, what seems impossible today might become undeniable tomorrow. The truth is, we simply don't know enough yet. We're still listening, still waiting, still wondering if someone or something out there might be calling us. The universe is vast, and our understanding of it is still in its infancy. But if fast radio bursts are indeed a message from the stars, one thing is certain: our curiosity will lead us to keep searching, keep asking, and one day perhaps find the answers we seek. Now, as we peer deeper into the universe, the mystery of fast radio bursts only seems to grow. We once believed these signals must be coming from galaxies filled with explosive energy, places where stars are being born or dying in fiery supernovae. But the universe, it seems, is full of surprises, because some of the most powerful FRBs we've detected come from the quietest corners of the cosmos. Take, for example, the case of FRBs coming from dwarf galaxies, small, faint galaxies with hardly any star formation. These places, which seem almost silent in the grand orchestra of the universe, are producing some of the most intense bursts of radio waves ever observed. It's as if the universe is playing its most powerful notes in the quietest places. But what does this mean? Could there be different types of FRBs coming from different environments and caused by completely separate phenomena? Perhaps some are born from violent events like neutron star collisions, while others emerge from galaxies with no visible activity. These bursts challenge our understanding of the universe's most extreme environments. And then there's the question of why we've detected so few FRBs from our own galaxy, the Milky Way. Is it that our instruments aren't sensitive enough to detect local bursts? Or are FRBs simply more common in distant galaxies? It's one of the many puzzles that make FRBs so intriguing and so elusive. Finally, there's another theory, one that could unlock a completely different aspect of our universe. As these radio waves travel across space, they pass through everything in their path, including the mysterious dark matter that makes up most of the universe. By studying FRBs, scientists hope to map the distribution of this invisible matter, revealing yet another layer of the universe's grand design. While the mystery of FRBs continues, our understanding of these bursts has been revolutionized by recent discoveries. One of the most significant breakthroughs comes from a powerful new tool, the Canadian Hydrogen Intensity Mapping Experiment, better known as CHIME. This cutting-edge radio telescope has detected hundreds of new FRBs, revealing patterns we've never seen before, especially when it comes to repeating bursts. Before CHIME, FRBs were considered rare, fleeting events, appearing once and then vanishing forever. But with CHIME, we've discovered repeating FRBs, bursts that occur again and again, sometimes from the same exact location. These repeating signals could be the key to unlocking the true nature of FRBs. And while CHIME has transformed our understanding, there's even more exciting technology on the horizon. The Square Kilometre Array, an international project set to be the world's largest radio telescope, will have the power to detect even fainter signals from deeper within the universe. With tools like these, we may soon be able to pinpoint the exact locations of FRBs and perhaps finally understand their cause. Imagine what we might discover next. Perhaps FRBs will unlock new secrets about the universe's most extreme environments, or even help us map the dark matter that binds galaxies together. With each new signal we detect, we take another step closer to solving one of the greatest cosmic mysteries of our time. So, where do we go from here? With every new burst detected, we inch closer to unraveling the mystery of fast radio bursts. But we're not there yet. The signals we've captured, while powerful, are still shrouded in uncertainty. That's where the next generation of technology comes in. Tools like the Square Kilometre Array will allow us to detect even the faintest whispers from the furthest corners of the universe. Once operational, it will be the largest and most sensitive radio telescope on Earth, capable of mapping the cosmos with precision we can barely imagine. Imagine this, a telescope powerful enough to pinpoint the exact location of these mysterious bursts and trace them back to their origins. Whether they come from neutron stars, black holes, or something entirely unknown, the Square Kilometre Array will give us the tools we need to find out. We're on the edge of a breakthrough, where the unknowns of today could become the discoveries of tomorrow. But that's not all. As these bursts travel across the universe, they interact with the invisible forces that shape everything, dark matter and dark energy. By studying FRBs, scientists hope to map these unseen forces, revealing the hidden structure of the universe. In other words, these signals may not just be answers in themselves, they could be the key to answering even bigger questions about the very fabric of reality. The universe is speaking to us in bursts, and for the first time, we have the technology to listen. What will we hear? What new secrets will we uncover? The future of FRB research is bright, and it's only just beginning. Here, at the end of our journey, we find ourselves with more questions than answers. But that's the beauty of exploration. The deeper we look into the cosmos, the more we realize how little we truly understand. Fast radio bursts, these fleeting, powerful signals from across the universe, may hold the key to unlocking some of the universe's greatest mysteries. Or they may be the starting point of an even larger puzzle. Are these bursts natural phenomena born from the universe's most extreme forces? Or could they be something more, something we've yet to even comprehend? The quest for answers drives us forward, and in every new discovery, we're reminded of the vastness of what we don't know. As the great Carl Sagan once said, somewhere something incredible is waiting to be known. And perhaps these signals are our invitation to find it. The universe is vast, and we are only at the beginning of our exploration. But as long as we continue to search, to question, to dream, we will keep moving forward. One signal, one burst, one discovery at a time.